Hello and welcome to TidyX episode 107. TidyX is a screencast where we go through and explain how our code works. My name is Ellis Hughes and you can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSPPatrick and at Tidy_Explained is where we both are on Twitter. That's the Twitter handle for the screencast. You can always tweet us and like and retweet and comment, etc. You can also open up a issue on the GitHub repo, or you can go over to YouTube, like and subscribe at the bottom of the YouTube page and drop some comments, questions, etc. in there. And we're happy to interact there as well. And we do have a Patreon page. We appreciate everybody who feels like they've benefited from this screencast and wants to contribute in any way. We're very obviously gracious of that. So thanks so much.
Exactly. Thank you all so much for doing that. All right. So we have been doing a bit of a series explaining how our objects works, kind of going back to basics to go, all right, here's this object. We talk about it all the time. We talk about data frames. We talk about vectors, and we just kind of assume you understand the nuances and the different things that exist. Obviously, we try to explain how we interact with them, but we didn't really spend a lot of time going through, here's how you create them, here's why they exist, here's a lot of the features. And so you kind of had to glean from our different episodes to figure out different ways you could use them. In this series, we're trying to go through and explain different object types that exist in R and the ways, how you create them, how you interact with them, their properties, so you can get a really full idea of a lot of the different ways that you can actually use it specifically. And so the last several episodes, we talked about dates and date time objects. We've talked about data frames and vectors. Last week, we talked about factors, which always confuse a lot of people. This week, we're going to do lists. So lists, I love lists. I use lists freaking all the time. You can look back at our code. I think lists are nearly in every single one of our scripts.
Pretty much, like, especially anytime we've done our web scraping, and the JSON parsing episode was a lot of lists. A lot of times when we write for loops, we'll store the results in a list. Lots of options.
It's just
they're super efficient, super fast. When you're dealing with large amounts of data, and particularly large amounts of data that have like grouping variables, it's pretty efficient and quick to split those out into designated lists per group to run your stats and whatever operations that you want to do. So we'll kind of build from the ground up. We'll talk a little bit about lists in this episode, and then maybe the next episode we'll get into some applied approaches of those lists in terms of stats and running functions over lists and things like that.
Exactly. And as you're watching this episode, if you haven't subscribed, definitely click the subscribe button down below. And if you have any ideas of things that you'd like to see us do with lists in this next episode, leave a comment down below. All right. So I'm going to share the screen so Patrick can also see what we're talking about here. And badoom. Here we are. All right. So lists. So let's get going on this. So lists, what are they? How do they work? Why do we use them? So a list, I think I almost default to lists a lot of the times, especially when I'm not quite sure, like as I'm starting to work on a project or on some code, because they're an object that can contain literally any other object nearly without limit, right? The way that they are constructed is you can basically throw any sort of data at it, different shapes, different sizes, different types, and it's like, yeah, sure, I'll hold on to that, not a big deal, and then I can use it later on. So if you remember from past episodes, for example, with like data frames, they are nice because the different like versus matrices they're nice because the different columns can be different types. Here, it takes it even to a next level where any element in that list can be any type, right? So there's no limits to what it can contain. And so kind of think of a list as it has a lot of different slots that you can store stuff in, and what that slot contains, it doesn't care. You can be whatever you want it to be, and so it's like infinitely flexible. You can access those elements by an index number, or if you've named that index, the name of that index. And then you can also, as you're like subsetting your lists, you can select multiple elements at a time, and it retains its form as a list. One quick note too, as we are going through this, we know that there are other types of lists that exist in the R world, such as an A list and a pair list. We're not going through that today. This is not something that most R users are going to come across on a regular basis, so we're not going to be going over those. And we already have enough to talk about lists.
Yeah.
Patrick, do you want to take us through this first set?
All right. So here we're just going to create a list. So obviously, if you run just the single comment list, it's just going to give you an empty list, and you'll see you've probably noticed if you've watched previous episodes, whenever we've done web scraping or something like that, usually we create an empty list to store the outcomes, to store the outputs. So that's all that is. We can then add some numbers into this list. So if we add those numbers and we run this, what we get returned is that those numbers are reflecting the indexes. So these are all empty, obviously, but we have six indexes, each with a corresponding value. So you can see Ellis is changing the element within each of these within each of the indexes. So index 1 has a value of 102540154. We can also then go through and we can run this next bit of code, and we can show how you can store a bunch of different things within a list. So like Ellis said, they're pretty flexible to handle just about any type of structure that you want. So here, Ellis, if we look at the code, you can see that his first element before that, or first element before that comma, is this vector of values 1 through 6. Then he puts a comma and he says, okay, in the next index, I'm going to store this cool little data frame. And that data frame has 2 columns with 10 rows. And then after the next column, he's got another index within this list, and that index has 4 indexes of its own. So we can take a look here at the bottom of the whole thing. So there you can see the 4 indexes. So he's got a list with a vector of numbers in one element. The second element contains a data frame, and the third element is a list nested within inside of a list. So this is actually a list of lists, right?
Whoa, man.
Yeah.
Lists of lists.
So you could see how this is, how efficient these things can be. And sometimes, like if you've worked with external data partners, sometimes you'll get data from their database that actually looks like this, where it's like lists or different types of data nested within lists. And so you have to kind of parse through all of that stuff. So that's why lists are very handy. They can store lots of things in one single list, and it's pretty cool. So we'll create our first list here. We have the first index of that list is called tidy list, or the first element. And then the next one, now here Ellis has named it. So tidy list is going to be in index 1, and it has no name. TidyX numbers in a list is actually a named index, and it's going to be a vector 1, 3, 5, 7, and 9. Okay, so you can name your so we'll run that. You can name the indexes just like similar to how you would build an empty data frame. So you'd give it column name equals, and then whatever you want under that column name. Same thing works when dealing with a list. So here we have the first. Oh, what are we doing? Yeah.
Just showing another way. Like the reason we put quotes around this is because this had spaces.
Because it has spaces, yeah. Mm-hmm.
And just like a named vector or a named anything basically in R, if it's like a valid entry, you can just type it in. If it's a name. Yep.
And so knowing what the how your indexes are named or numbered, is important because that's going to dictate how you can call these things, or the ease of calling these things, the way that you call these things, which we'll get into here next. So here we go.
All right. So a cool thing about lists, or the value of lists that I think exists is lists. Obviously, we've touched on this a lot. Is that they're super flexible. They can contain like an infinite number of different things. They can be really long. They can be really nested. Contain lots of information. But because of that, there is then a limited amount of information that you can get. Like there's a limited amount of information that exists to just like pull out some structural information about the lists, like built into R. Like you can, once you've built your list, you could write functions and whatnot to pull out information for you. But there's only a couple functions that exist that I'm aware of, at least, that I use on a regular basis to pull information out of the list, like to understand what is the structure of it. So the first one is the length function, which tells me the length of the list. So how many elements exist in the list. It's kind of like when you're dealing with data frames and you use n row or n col to give you the number of rows, number of columns. Length is the number of elements that exist in that list. The next function is lengths with an S, not to be confused with length, the original, or the other one. So lengths iterates over all the elements of your list and tells you then the length of every single element in that list. And so this can be valuable if you want to understand the structure of the contents of your list. Once you know, okay, I know I've got 2 elements now. What are those? What is the information about those? And then the next thing is names. So these are, if you have named elements, it'll pull this out for you. So in first list, we know that we have one element that is unnamed and one element that is named. So if we call names on this, the elements that are unnamed are empty quotes. So right, that's an empty string. And then the second element is the TidyX numbers in a list. So this is the name of that element. So that's that gives us information about that. One thing to note, though, as you're working with a list, if you create a list that has no names in it at all, you might think that you'll get a vector of empty strings, indicating the number of indices, and then because all of them have no names, they'll just be blank. But no, if you call names on an unnamed list, it returns null. And so this is different behavior based on the way the list is constructed. And so to be careful when you're working with this names function, you'll probably always want to check to see if it returns null, if there's the potential for there to be your list returned without names. It's just a thing to kind of be aware of as you're working on it, so you don't, get weird errors, or you will get errors in your code if you don't handle this properly.
Mm-hmm.
So now those are some of the properties that exist in lists, but how do we access the contents? We've stored them in our list when we constructed it. How do we access the contents, or put stuff in or pull stuff out? And those are with the square braces, just like the vectors and other object types that we've worked with in the past. One thing to note is there's the single square brace, the double square brace, and the $sign. So this confuses a lot of beginning programmers. Not surprisingly, it's kind of weird to think about a list in this way, but think of a square brace as if you are identifying, you're subsetting your list, either positive, so you have a numeric index, or the list of names of the list that you're wanting to pull out, but it'll preserve it as a list still. And that's important because with the double square brace, that actually returns the contents of an element. It can only accept a vector of length 1, so you can't grab like 3 or 4 different elements and pull out their contents, because that doesn't make a whole bunch of sense when you're trying to assign it out. Like, how do you store that? And so double square braces accepts a vector of length 1, and it can be the index that you're trying to pull from. And note also in R, we use indexes base 1, not base 0, as other languages might use.
Python.
What? No other languages. And then if the element does not exist in the list, it won't fail. It doesn't return an error like vectors do, because lists are infinitely flexible. It just returns null. So it'll return a null value. And so this is another thing, like this is valuable, and if you have code that you don't want to fail, so you can check to see then if it returns null if you try to pull that element out and then react accordingly. So it is actually very valuable that it doesn't just error out when you try to pull out an element that doesn't exist in R or in the list. And then if you have names, you can use standard $sign notation like you do in your vectors and in your data frames and whatnot. Patrick, do you want to take us through actually doing this?
Yeah. So we have our first list. So just run the first list so we remember that what that looks like. That's the tidy list, which is unnamed, and then the tidy numbers in a list, which has a name, has a vector underneath it of odd numbers. So if we want to get that first index, the elements in that first index, we call this. Notice that, as Ellis said, it retains the properties of a list. So it's still a list. Yeah, we could check the class, and it's still a list, right? You can see the double bracket 1 up above it. We could do this on, yeah, there you go. It's character. We'll check that in a second. So we could run this on number 2. We get that list element of 1359 underneath index TidyX numbers in a list. We can also call number 2 with the $sign. Notice we have to use the little single hashes there because there are spaces between the name of that index. If there weren't spaces, this wouldn't be a problem, but we have to do that so that R knows that that's all contained together, right? Mm-hmm. We can also call the variable. So remember, above, we're calling those indexes and we're getting returned the list. With the exception of that one, not with the $sign. That $sign is returning the actual variables within the list, which looks like that, right? So we could do it like that, or we can actually call with both types of brackets. So here we're taking our list and we're saying, give me the second index, which is tidy numbers in a list, and then give me the first element within that list index. So there we get the 1359, or we can just double bracket the second index and we'll get returned back to us the actual elements within that. We can do this in tidyverse too. So if we take our first list and we pipe in .1, that's going to return back to us. Oh, I think we need tidyverse loaded. Yep.
Skip that. My bad.
And if we run it now, that returns back to us that list index of 1, and we can do this for index of 2 as well. And then again, we can use our double brackets if we want to actually get the elements within index 2. We just pipe in a double bracket for that first element within index 2. And of course, these are all like long and ugly. We can do this in 2 lines of code with the purrr function's pluck function, which we've used before when web scraping. So here we're just going to pluck index 2, and pluck automatically will return back to us the elements within index 2. So here we get 1, 3, 5, 7, and 9 again.
Exactly.
And so that's how we call some of those things. And now we can iterate over these lists and do some, just get some like general summary statistics if we're dealing with mathematical numbers and things like that.
Mm-hmm. Exactly. So with lists, we're going to show you some of the ways you can interact with it in base R, and which is valuable to understand and know. I think that it's just good to know kind of base R stuff on top of tidyverse, because both are just tools in your toolbox. You use it wherever it makes sense. So let's construct a list for us to start doing some of these mathematical operations on. So we're going to set our seed so it's reproducible, and we're going to construct an unnamed list with 3 different elements that are containing 3 vectors from the uniform distribution. We're going to have 10 entries in each one.
Yep.
So we set that up. Cool. So we've got our list here. So the way that you might do this in base R without using some of the more advanced tools is you might do this in a for loop. So the way you can do that, and if you want to store the values out, what you do is you want to store it in a list. So there's a couple constraints here that we're trying to do. You create a new empty list, and we'll just call this simple list mean, because we're going to calculate the mean of each of these entries here. Now with the for loop, we're going to go for I, so this is our index that'll increment over time in seek along simple list. So this will say this is going to give us the indexes for all the entries in simple list. You could also do like seek len simple list, or 1 to length of simple list if you wanted to. 1 to length. I swear I can type. Is another way you could write it too, but this is a little bit less like protected in a sense, because you don't know if simple list will be a length greater than 1, guaranteed. But anyway, so you're going to do this for loop, and then what we're going to do is we're going to take the mean of the simple list entry. We're going to use the double braces because we want the contents of the list at index I, and we're going to do NARM is true, just in case there were NAs in our data set. And then we're going to assign it to simple list mean at index I. Note we need to use the double braces here because we want to insert into the element I.
And that's a super important. So in the for call, you're actually specifying the seek along simple list. So you're actually specifying the index within each of those lists. So the double brackets within the for loop are dumping the elements out. And this is one where, even though I know this, I will always mess this up, and I'll write a for loop and I'll get a bunch of errors about my indexes because I do that. And I'm like, So it is a really important one to remember, is once you're inside of those curly brackets, you're dealing with and depositing the results into each individual list index.
Yeah. I mean, you can alternately do this, because in order to insert into this, because you're dealing with a list object at this point, you could say, hey, this is a list object, just drop this into that spot. And it's like, okay, no problem.
Yeah.
But
more code.
Yeah.
Yeah.
It's more complicated, but there's situations where this makes sense too. So, or I have recently dealt with situations that do that. All right. So we're going to run this. Runs pretty quick because it's a pretty simple code. As you can see, we got our values of mean for the 3 entries here. Not too surprising what those values are, since we're R uniform. It'll be centered around 0.5-ish. We only have 10 entries, so they're going to be a little bit off. All right. But that was actually not a small amount of code to get a simple mean value for this list here. What are other ways that we could do this? So base R has a lot of really cool functions that exist. One I use literally all the time is Laplay. So it stands for like list apply. So you enter in a list or a vector, and it'll iterate over each one of the elements, apply some function to the element or the contents of that element, and here you list the additional arguments that exist and the values you want to exist for this function. And so you can read this as list over, or loop over simple list, apply the function mean to the contents, or each element contents, and also set the argument NARM for mean to be true. So we can run that, and list apply will always return a list, or lapply will always return a list. And so we have a list here of the values that are same as what we calculated before, because it's the exact same thing, just much, much, much shorter code. Then there is supply, or simple apply. Simple apply you can read in a similar way, where we have the list that we're trying to iterate over, the function we want to apply to the elements, the arguments that we want to set for this function. But then there's this simplify argument that exists. And this impacts the supply function, where this is saying simplify is false and true. So we wanted to show what happens when you run one versus the other. So let's run simplify as false. It returns a list because supply did not try to simplify its contents. Therefore, the simplest way to store information as it loops over it is a list, right? Because that list can contain everything. But if you set simplify to true, it'll run it, and it actually returns a numeric vector for us because it simplified it into the simplest form that output could do. And in this case,
I think that's the default. Simplify is true, I believe, is the default.
Yes. So this is by default. And so this is really nice because, hey, rather than having to work with a list, we now just have this this vector of double or of numeric values. We can work with that. We know how to deal with that. That's not a big deal. We don't have to deal with lists. The trouble is if you have a function here that might not return the same thing consistently. And then supply gets really confusing and really wonky. And some of the time, if it returns only doubles, it'll simplify it down into a numeric vector. But if sometimes this function returns like a data frame or something, you go, I don't know what to do, and then we'll return a list. And then your code needs to be able to handle that, and it's confusing, and you're sad, and you're like get frustrated, and not ideal. So the kind folks at our studio have, and the developers of Tidyverse, of course, wrote a better way and nice way to work with lists and iteration using specifically this is the purrr package, Purrr. So 3 R's, because we love R. Patrick, do you want to take us through these examples?
Yep. So this is these ones I'll use pretty much every day. Simple list we're taking, and we're going to use the map function and pass it the function mean. NARM is false in case there's any NAs within our list, which there's not. And this returns back to us. Map will return back to us a list. Super easy to do. The other way we can do the exact same thing with the map function. This is probably more apropos to what you would see with Tidyverse, or if you were doing other functions within Tidyverse, is to use the tilde in front of the function. So now it's going to behave like a function, and we pass .x, which is saying we want to use that simple list on the left side of our pipe. And so this looks a little bit more like we would probably normally write it. This is how I would write it if I was doing it. It's going to return back the exact same outcome, though, no matter which way you do it. We can also notice that our list has unnamed indexes. So they're just 1, 2, and 3. If we wanted to name those so that maybe I'm working on some code and I want to name them so I can then tell Ellis hey, check out the mean of run 3, we can set those names. And this is just like we've done a billion times in data frames in Tidyverse. We use the set names function, and we pass the names within the order that we want to name. If we're doing data frames to columns, in this case, we're doing lists. So it's going to be run 1, run 2, and run 3. So now they're going to be named. You can see that. We run the map, and now we have the same result numerically of the means. We just have our indexes now named, which makes it a little bit easier to call, a little bit more specific to call. We can also return the results as a double with the map double. Same type of syntax there for the mean. This is going to return the results like the simplify with the simple equals true argument. So there we see the same type of results. We get a numeric vector passed back to us. And then finally, if we want to put these results of a list, let's say we're dealing with a whole bunch of data sets of lists, or a list of a whole bunch of data frames. We want to do some sort of numeric type of function like a mean, but we want to get it returned back to us as a data frame so that maybe we can put it into a table for a report or something like that. Lists don't look really cool in reports, but data frames do. We got to set the names first, because otherwise map DFR won't know what to do if the indexes are numeric. And then the next thing we do is we call map DFR, the same syntax. And now you can see down there in the console, we get this nice little tibble returned back to us where we have run 1, run 2, and run 3 as their own columns, and the mean sitting nicely below them. And I think that's the last one. Is the one below it the same thing? Yeah. You were so excited, you doubled it up.
Did it
so
twice.
We could delete that one. And then the last one is let's say that for whatever bizarre, strange, bizarro world we were living in, we were like, gosh, I'd really love to look at these means instead of numeric as character variables. Let's go ahead and do map character. And now you could see that we get the means returned back to us, but they have the quotation marks around them because they're no longer being evaluated as numbers. They're being evaluated as characters. I honestly don't know why you would want to do that.
So part of the reason...
Trying to think of when you would, but
with
yeah.
map, it's nice because you can specify the type that you expect to get out.
Right.
And so it's nice because that way you can have a consistent output that you always know it'll go to this thing. So you can go map CHR to get character, map call, which is apparently retired, so let's not talk about that one. But you can specify the type of output that you want, so like map logical, and it'll try to convert them into that format, which is why like these were simple numbers, so it could totally convert those into character. But if it can't convert them into a character, that means that you got an unexpected value in your list output, which means it'll error and go, hey dog, I don't know what to do with this.
Don't know what that is.
You said you wanted character outputs, but this is a data frame. I can't convert that into a character. Right. And so it like kind of saves you from yourself a little bit from doing that. And so
I need a lot of saving from myself sometimes.
Yeah, so this is like simple, like not error checking, but like a logic checking as you go, and it kind of helps you out. I wish it did like give you a little bit more context sometimes, but for loops also don't give you much context when they error out, so I can't blame anybody for that. But yeah, so that is kind of a lean, mean intro to lists. We have only like scratched the surface on the usability and the different ways that lists are valuable. This is just like the common ways that we see lists being used. And we look forward to getting into more complicated uses of a list. If you have questions about lists and situations that you've run across, definitely leave a comment down below. We love to hear from you guys about the various things that you're seeing in our screencast, how it's helping you, questions that you have. We just love hearing from you. So with that, I guess we're gonna call it. As always, my name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSP Patrick, and Tidy Explained is on Twitter at Tidy_explained. We're also on Gmail at tidy.explained@gmail. The GitHub issues section is always opened if you'd like to take one out there, or you can simply go over to the YouTube channel, like and subscribe, and then drop comments, questions, and thoughts down below. And as always, we're very appreciative of anyone who's found the screencast to be useful and impactful and wants to contribute to our work in any way. The Patreon page is open as well, so we thank you for that.
All right, thank you all so much, and keep on exploring your world.